Hello everyone, welcome to the second video of A-Level Computer Science. In this video, we are going to talk about numbers and quantities. In the last video, we discussed about binary, ternary, and hexadecimal. And here are answers to the questions I left at the end of the video. Hope you get them all correct. In this video, we will learn file sizes. The file sizes can be explained using the units of bit, byte, and kibibyte. And also, we will distinguish between kilobyte and kibibyte. In computers, we store different types of files, including photos, music, and text. These are all like our boxes, the thing that we need to deliver with a truck. When we move these files onto the USB drive, this file will occupy a certain space on it, and if we put too much, they will run into red on the local C drive, and sometimes an error sign will show if the space is not enough. But how these spaces are calculated? Well, we know that the computer files of photos, images, and sound are all making of zeros and ones. But exactly how large is it? So first of all, we are going to define a minimum size in computer science, which is called a bit. One bit is made up of a single zero or a single one. And the bit is a short abbreviation of binary digit, which we pick up the first two letters from binary and the last letter from digit. So for example here, this 0 is 1 bit, this 1 is 1 bit, and this total is 8 bits. In order to distinguish different digits in a number, we give them a name to each digit. Starting from the right-hand side, it's called bit 0, bit 1, bit 2, each with a power of 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2, and so on. So here will be bit 3, bit 4, bit 5, bit 6, and bit 7. Well, if we only have bits, this will be a problem. For example, the image file shown here has 56,551,536 bits, which the number gets too large and it's hard for us to remember and compare. So in order to solve this problem, we have larger unit. For example, nibble. A nibble is a group of 4 bits, so 4 individual ones and zeros. 1 nibble is equal to 4 bits. And for the units that's slightly larger than nibble is called byte, and 1 byte is composed of 2 nibbles. So 1 byte is equal to 2 nibbles equal to 8 bits. And the typical English letter can be represented with 8 bits, occupying a space of 1 byte. And this number, this binary sequence 0100000001 is exactly the binary representation of the letter A. Okay, here we are going to do a small exercise. Hello World is usually the first program written down by a programmer. How many bytes should this sentence take? What about nibbles? What about bits? Take a second and think about it. You can pause the video here and try to figure out the answer. I suppose you all got the answer yourselves. So I'm gonna review the answer. Oh, if we count the word here, hello world is made out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's made out of 12 letters and symbols. So which means that it should be 12 bytes, which is 24 nibbles and 96 bits. Did you get them all correct? Okay, I'm going to do a small summary of what we have learned so far. So the smallest unit is bit, and the larger one nibble, and the largest one is byte. So 1 byte is 2 nibbles is equal to 8 bits. However, the problem still exists with this photo file. It will be slightly smaller if it's represented with bytes compared to bits, which will be 7,068,942 bytes, but is still kind of large. Then we are going to use prefix. to solve this problem. You may already have this idea in other units such as physics and chemistry. In physics, we use decimal prefix for large quantities. For example, 1 kilojoule is equal to 1,000 joules, and 1 megajoule is equal to 1 times 10 to the power of 6 joules. So in computer science, we have similar stuff, but as the numbers are using base 2 number system. Then instead of using 1000, we use 1024, which is 2 to the power of 10 when converting. So for example, 1 kibibyte is equal to 1024 bytes, and 1 megabyte is equal to 1024 kibibytes. Here, we need to make a comparison between kilo and kibi. When we learn in other units, for example, we say 1 kilogram is equal to 1,000 grams, 1 kilometer is equal to 1,000 meters, and 1 kilobyte, well, if we use 1 kilobyte, it's supposed to be equal to 1,000 bytes. However, in the early age, when the computer was in developing, the word kilobyte can mean 1,000 bytes and 1,024 bytes at the same time, which makes people get confused. So later on, in a meeting of an ISI unit, people decide to use a new unit called kibibyte for computing only, which has a rate of 1024 to make it distinguish between kilo and kibi. So what I'm going to say here is 1 kilobyte is equal to 1,000 bytes, which has the euro meaning of kilo. But on the other hand, 1 kibibyte is equal to 1024 bytes, which is a meaning that we use particularly in computer science. So here the bi, kibi, b means binary. So it means kilo binary byte. So we called it kibibyte. And now we are going to see how the binary prefix conversion works. So from the smallest unit bit, if we times 4, we get nibble. If we times 2, we have byte. And from byte to kibibyte, we have 1024. From kibibyte to megabyte, we have 1024. And from megabyte to gigabyte, we have 1024. And from gigabyte to terabyte, we have 1024. So all of these units are growing up in the same order as physics, but instead of 1000, we use 1024. Okay, so after learning that, we will see how we can use the knowledge to convert the bytes into kibibytes. So for example, 34560 bytes can be converted to kibibyte by developing 1024. And 3,456,000 bytes can be converted to megabytes by divided by 1024 two times, which is 3.296 megabyte. However, we know all of these ones, we know how to do the conversion, but exactly intuitively, how large is it for 1 kilobyte, 1 megabyte, and 1 gigabyte? Well, a text file is approximately 1 kibibyte, and an image file is approximately 1 megabyte, and a game file is usually 1 gigabyte, but modern game files are much larger than that, which is approximately maybe 5 gigabytes, or some of them maybe 10 gigabytes, or even larger. And the typical solid-state drive has a storage space of 1 terabyte, which is 1024 gigabytes. Pretty large, huh? But we have even larger solid-state drive nowadays. For example, 5 terabytes is common. After learning all of this, we can do an example, an exercise about the binary prefix conversion. So for the PowerPoint file here, it occupies a space of 830 kibibyte. How many bytes is it? And how many bits is it? You can stop the video here and think about the answer. I hope all of you get the answer now. I'm gonna review it. So the first one should be 849920 and the second one should be 6799360. Hope you get them correct. Here's a small summary about what we have learned in this short video. So the smallest unit, each single 0 and 1, is called a bit, and 4-bit is a nibble, and 1 byte is made of 2 nibbles. And 1 kilobyte, kibibyte has 1024 bytes in it, and 1 megabyte has 1024 kibibytes in it, and gigabyte and terabyte and so on. And all of these are in an order which increased by 1024. Okay, at the end of this video, let's do a quick exercise together to test your knowledge. So first of all, 8 bits is equal to what on the right? Is it 1 kibibyte, gigabyte, 1 byte, kilobyte, blah, blah, blah? Yeah, this is easy. So 8 bits should be 1 byte. What about 8,000 bits? This one is a bit tricky. Well, 8,000 bits is, if you divide it by 8, which is 1,000 bytes. Well, when we say 1,000 bytes, it is using the kilobytes notation. So we said earlier, 1 kilobyte is equal to 1,000 bytes, and 1 kibibyte is equal to 1024 bytes. So for the question here, which is 1,000 bytes, which should be 1 kilobyte. Okay, this is the end of the video. Hope to see you in the next one.